All right, let's talk about one of the most frustrating errors that any developer or DBA can run into, the dreaded SQL Server deadlock.
And to crack this case, we're going to have to go deep, really deep, inside the database engine. By the end of this, you won't be a victim of deadlocks anymore. Nope, you're going to be the detective.
Okay, so first things first, let's investigate the crime scene itself. What in the world is a deadlock, really?
So picture this. A deadlock is what happens when two or even more tasks get completely stuck, permanently blocking each other. Each one is waiting for a resource that the other one is holding. The classic analogy, and it's a good one, is two people trying to walk through a revolving door from opposite sides. They're just stuck. It's a total standoff, a deadly embrace, as it's sometimes called.
Now, this is super important. Don't mix up a deadlock with just normal blocking. Blocking happens all the time. It's just one process waiting in line for another one to finish up with a resource. It's a totally normal, expected part of life in a busy database. A deadlock, though, that's a whole different beast. It's an error condition. There is no line. It's a circular standoff, and the only way out is for SQL Server to step in and, well, take someone out.
All right, let's walk through a classic crime scene step by step. So, you've got transaction A. It kicks off, and the first thing it needs to do is update the supplier table. No problem. It acquires a lock on that table. So far, so good, right?
At the exact same time, over on another thread, we've got transaction B. It's doing its own thing, and it needs to update the part table. So it goes ahead and locks that. You see where we are? Both transactions are now holding a resource, minding their own business.
And here's where it all goes wrong. Transaction A, still holding that lock on the supplier table, now says, okay, next I need the part table. But, it can't get it. Why? Because transaction B has it locked. So transaction A just sits there and waits.
And for the final, fatal piece of the puzzle, transaction B, still happily holding its lock on the part table, now tries to get the supplier table. But who has that? Transaction A. Boom. That's it. That is the deadly embrace. We've got a perfect circle. A is waiting for B, and B is waiting for A. Left to their own devices, they will wait forever.
So if they're going to wait forever, what happens? Does the server just grind to a halt? Well, no. This is where our hero, SQL Server's own internal detective, the lock monitor, comes on the scene to break things up.
See, SQL Server has this background process running all the time. It's called the lock monitor. Think of it like a security guard on patrol. And by default, its route takes about 5 seconds. Every 5 seconds, it's checking any deadlocks, any circular dependencies here.
But here's a really cool part. The system is smart. If it starts seeing deadlocks pop up all over the place, it doesn't stick to that 5-second schedule. Oh no. It speeds up its patrol, checking as often as every 100 milliseconds to catch and resolve these problems way faster. Pretty neat, huh? So when the lock monitor does find one of these standoffs, it can't just, ask them to play nice. It has to act. It has to make a tough call and choose a victim to break the cycle. So how does it choose who gets the axe? Well, by default, its logic is purely economical. It looks at the transactions stuck in the deadlock and picks the one that would be the least expensive to roll back. Basically, it kills the transaction that has done the least amount of work, because that's the easiest one to clean up after. But you are not powerless here. You can actually influence this decision. You can set something called a deadlock priority for your transactions. You can literally tell SQL Server, hey, this process is super important. Don't kill it. And it'll listen. It will always choose the process with the lowest priority as the victim. Only if the priorities are the same does it fall back to that least expensive calculation. So once the victim is chosen, it's terminated instantly. Its work is rolled back, and all the locks it was holding are released. Poof! The deadly embrace is broken. The other transaction can now grab the resource it needed and finish its job. And what about the application that ran the victim transaction? Well, it gets that lovely error message 1205. Okay, so the immediate crisis is averted, but the case isn't closed. Now it gets handed to you. It's your turn to put on the detective hat, to sift through the evidence and figure out what went wrong so it doesn't happen again. And your number one tool in this investigation? It's the XML deadlock report. You capture this using something called extended events, which is the modern, super efficient way to trace what's happening inside SQL Server. This is absolutely the way to go because it gives you everything you need without bogging down your server.
I really want to stress this. Be so careful with the old school methods like trace flags 1204 and 1222. Microsoft themselves will tell you, hey, don't use these on a busy system. And there's a good reason why. Writing all that text to the error log can hammer your disk I/O and can actually slow down the lock monitor itself. You could literally make the problem worse. So yeah, stick with extended events.
So what's in this XML report? It's basically the entire case file. You've got the victim list, which tells you which process was killed. You've got the process list, which details every single process involved, what they were, what SQL they were running. And you get the resource list, which tells you the exact thing they were fighting over, down to the specific key, row, or page.
All right, so solving the mystery of what happened is great, but a truly great detective prevents future crimes. So let's talk about prevention. How do we harden our code so this stuff just stops happening? There are a few key rules here that can make a huge difference. But if you remember just one thing from this entire explainer, make it this. Access objects in the same order every single time. Think back to our example. If every piece of code in your entire system that needs the supplier and part tables always locks supplier first and then part, that deadlock we saw earlier, it becomes logically impossible. Another really powerful tool for your arsenal is something called row versioning. When you enable an isolation level like read committed snapshot, you kind of change the game. Instead of readers waiting for writers, SQL Server just keeps a copy of the old version of the data around for a bit. So when a query comes along that just needs to read, it doesn't have to take a lock or wait. It just reads the last committed version. It's an amazing way to keep readers and writers from tripping over each other. So, there you have it. You're no longer a victim. You're officially a deadlock detective. The next step is to take this knowledge back to your own code. Really think about it. Where do you have long transactions? Are you accessing your tables in a consistent order? Could row versioning solve some of your headaches? It's time to start your own crime prevention initiative.